Assalamualaikum. It's almost 11 and there are two of you. Hopefully you can hear me clearly. Good morning, everyone. So inshallah today we won't be spending the entire 2 hours, but instead we'll just optimize our time, probably 1 hour or a bit longer than that, to discuss on this chapter, which is a new phase in the syllabus, which is not to say benda ni baru, tapi dia macam lompat sikit lah daripada yang standard kita dah lalu sebelum ni, chapter 8 and chapter 9, waves and superposition kan. So kita masuk kepada topik electric fields. So basically there are going to be 3 more chapters for your AS syllabus. So those 3 chapters kira macam adik-beradik lah kan. Tapi the content has still got something to do with the previous chapters lah. It's not segregated or separated by itself. But cuma mungkin dia punya terminologies dia tu is quite different compared to the others. But the concepts, the underlying understanding, they're basically the same. So good morning everyone, inshallah. We'll just wait a few more minutes, hopefully not too long. Once we have a considerable number of students here watching, probably around 15, then we can commence. Dia cuma ralat sikit lah because
kita akan start. The video has been started for the past 5 to 10 minutes kan. So nanti kalau siapa yang nak view balik video ni dalam Facebook group ni, dia kena cursor dia tu dia kena terus jump to after 5 minutes. So hopefully everyone is doing well. We are in the last day of Sya'ban. InsyaAllah Maghrib ni akan masuk Ramadan. Allahumma balighna Ramadan. Anything can still happen within these few hours. We'll just have to hope for the best from Allah Subhanahu wa Ta'ala. Tomorrow will be the first day of Ramadan, the month of Ramadan. Sementara tunggu sampai 15 ni bagi tazkirah pagi sikit lah. In the hadith, Rasulullah SAW said, when the month of Ramadan arrives, do not say Ja'a Ramadan. We do not say has come upon us Ramadan, but instead we have to say Ja'a Shahru Ramadan, which is has come upon us the month of Ramadan. Because based on madhab Shafi'i, the scholars from the Shafi'iyah madhab, they say that Ramadan is a very, very unique name of Allah Subhanahu wa Ta'ala. So it is quite inconvenient for us actually to say Ramadan has arrived, but instead we should say Shahrul Ramadan, or the month of Ramadan itself has arrived. So tazkirah ringkas. Sementara tunggu 15 orang. Maaf pagi-pagi dah tazkirah. So selamat pagi semua. Hopefully everyone is doing well. Thank you very much for those who have filled up my survey form, the optional survey form. As expected, not all of you actually fill in the form for some reason. I don't know why. Probably because panjang sangat kot, banyak sangat soalan. Ada 10 soalan survey nak kena minta tolong isi. So out of 18, I think roughly around 10 ke sikit lah, 13 orang je yang isi kan. So hopefully you guys can remind others kau terlepas pandang kan, untuk nak tolonglah isi survey tu, so that nak tahu je lah, nak tahu feedback you guys. Sebab kita online kan, so online ni dia payah sikit. Tapi kita cubalah, this is the new norm kan. Kalau in certain universities, in certain higher education universities, contoh macam dekat Uniza, they've already given a statement, although the PKP ataupun RMO, banyak sangat nama, RMO, MCO, apa-apa je lah kan, bila dah habis pun PKP, all lectures still need to be conducted online. So that is the case for certain higher institution education dekat Malaysia ni lah. So we still have yet to know what is going on, what will happen after this. We just have to pray for the best. So as of now, we look forward for the lifting of the PKP, so that things that we cannot do right now can be done lah. So tapi tak tahu lah kan, habis PKP ni dah Ramadan, lepas tu dah nak Syawal pula, lepas tu takkanlah time tu baru nak balik college kan. Tapi raya kali ni pun bukannya boleh pergi balik kampung apa semua tu kan. So tak apa, kita just pray for the best lah. Halu Okay, so masih lagi menunggu, insyaAllah. The class rep is here, so probably we can just start lah kan. The class rep, dia memang datang awal lah kan, dia tadi lagi. Alright, insyaAllah. Bismillahirrahmanirrahim. We'll start with Kitab Al-Fatiha. Alhamdulillah Rabbil Alamin, Ar-Rahmanir-Rahim, Maliki Yawmiddin, Iyyaka na'budu wa iyyaka nasta'in, ihdinas siratal mustaqim, siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, respected students, Alhamdulillah, we will continue with our tutorial question review on this chapter, which is chapter 10, electric fields. I gave you the questions yesterday, so hopefully you have already gone through the questions and tried or attempted to do them yourselves. Inshallah, for this morning we'll just discuss and review together. Hopefully with that and also your feedbacks, the feedback notes that you've submitted, Alhamdulillah, thank you very much. I've read all of them. It's a matter of responding to certain questions that have been posed by some of you in the feedback notes. Inshallah, I'll try to address them also in this tutorial question review session. So hopefully we can make the best out of our session. Any comments, please leave it here, and any questions you can just ask straight away, inshallah. Electric fields, so I think half of you raised the concern of this is one of the most challenging aspects or topics in physics. So we pray to Allah subhanahu wa ta'ala that Allah make it ease for us to understand the subject matter on this, inshallah. So the question that we're looking at, the first question, there are only two questions basically. The first question is to state what is meant by an electric field. So if you can, if you observe carefully, based on the two questions that I've posted up to you, there is one on the definition on electric field, which is this question, and the other one is the definition of electric field strength. So basically, it's more on the concept and the formulas involved, inshallah. So quoting from the notes directly, electric field is a region of space where a stationary charge experiences a force. So we have to define it as a region or a space, namanya satu kawasan lah, yang mana when there is a stationary charge in the midst of that space, it will experience a force, where we call this force as the electric force lah. Okay, so that is an electric field. It has nothing to do with electric field strength. So kalau dia ada EFS, so electric field strength, so that's where the formulas come in. But when we talk about electric field per se, so it is just a matter of the lines. Kalau kat bawah soalan di bawah kan, so this is just concerning the lines and not the values and whatnot. Okay, so it's just a space. Part B, can you guys hear me clearly? Dia macam tak tahu response. So kalau boleh ada interaction bagus juga sebenarnya kan. Cuma ni interaction via comment sajalah kan. Okay, the electric field between an earth ni maknanya di bumi kan the electric field between an earth metal plate and two charged metal spheres is illustrated in figure 5.1. So sebenarnya dia punya lita ataupun dia punya circuit is bigger lah kan. So there should be a wire connecting to the first metal sphere, charged metal sphere, and also there's another one, and it is connected to a power source ataupun electrical power source. So that's where the electricity comes in. And then we have a space, a region of space, where we have an earth metal plate here. So on figure 5.1, label each sphere with positive or negative to show its charge. So we can see from here the direction of the electric field lines, the lines Actually, the line do represent the strength of the electric field. So we know everything goes from positive to negative. So that is the concept. So the concept of electric field, the direction of the electric field is going outside. Kalau positif kan, kalau negatif dia going inside. So dia macam a positive person, he is always looking outside. Dia sentiasa akan tengok ke depan kan. Kalau positive person lah kan. Kalau negative person ni asalnya dia akan banyak muhasabah diri yang melampau kan. Dia terlalu negatif, dia selalu tengok dalam. So dia jadi negatif je kan. So contoh lah analogi kan, lebih kurang macam tu lah kan. You got a positive person and a negative person, but apa yang menariknya, they all complement each other. The positive person, dia attract to the negative person, and they try to neutralize everything, make sure the electric current flows correctly. Lebih kurang lah, halal Okay, so the strength of the electric field is indicated by the closeness of the lines, i.e. closer lines indicate stronger field. So benda ni, this statement is actually answering the part 2 lah kan. On figure 5.1, mark a region where the magnitude of the electric field is either constant or decreasing. So ni macam agak challenging kot susah sikit lah nak jawab. Tapi kalau siapa yang boleh jawab, okey lah kan. Sebab kalau you jawab, nanti you rujuk dia punya schematic answer. Jawapan schematic answer tu agak vague kan. So try to give a more descriptive answer for us to understand. So first, untuk kita nak mark the region where the magnitude is constant or decreasing, we need to understand when we have a diagram of an electric field, the electric field lines actually indicates the strength of the field. So when the lines are closer, it shows higher intensity somehow. Dia macam inverse square law juga lah so the closer the lines, the stronger the electric field strength. So if the lines are further apart, so it shows a decrease ataupun the strength is lower compared to the closer lines. So from the closer line to the further lines, so kat situ akan ada decrease in electric field strength lah kan. And then if the electric field lines are actually spaced out constantly, that's where we have a constant magnitude of the electric field. Okay, so if you understand, please say I. Macam siapa nama? Dr. Azizah Osman. Okay, motivation sikit lah. If you understand, say I. Okay, mark a region where the magnitude of the electric field is constant. So what do? Based on here, we just have to determine the regions in which the spacing are actually constant. Maknanya dia tidaklah berkurang dan dia tidaklah menambah. So where it is constant, it's actually in the central part of the plate. Near the plate, if we zoom in, kalau lah kita nak zoom in kan, tapi ni sampai tahan. So near the earth metal plate, all of the electric field strength are actually parallel to each other. So when you have parallel kat situ, maknanya dia constant lah. Tapi sebab kalau dia curve, so the region is not constant. So this is where we can define ataupun label the region as C. So I placed here, kat sini pun boleh juga, somewhere in the central. Sebab kalau dalam dia punya schematic answer kan, within 5 mm from the central. So lebih kurang 5 mm dia kena ukur kan. Lepas tu 10 mm kalau dia betul-betul kat tengah-tengah. Okay, so these are the regions where you have constant electric field. And then moving on, mark a region where the magnitude of the electric field is decreasing. So decreasing is from the magnitude lah. The magnitude is decreasing. You have closer lines going to further lines. So on any line that gets further is considered as decreasing, the decreasing lines. So yang ni sebenarnya dia bukanlah trapezoid kan. Dia kena ikut dia punya the shape of the electric field lines. Tapi you get the picture lah kan. So if you label any point here, then it is actually indicating that there is a decrease in electric field strength. Okay. Moving on. So dia macam okay lah so 1 mark, straightforward. Right, part C. Still no calculation at the moment kan. So part A, part B, part C. Part A and B, no calculation, going to part C. So part C, a molecule has its center P of positive charge situated at a distance of 2.8 10 to the power minus 10 meters from its center N of negative charge, as illustrated in figure 5.2. Okay, we've got a molecule. So dalam molecule ni dia ada charge. We've got positive charge and negative charge. So kat sini dia macam it is in equilibrium lah, because it is not moving. But it is not moving in a sense that it is stationary within an applied electric field. Okay, so the molecule is situated in a uniform electric field of field strength 5 times 10 to the power 4 volts per meter. So kat sini dia adalah definition yang you kena watch out lah kan. Electric field strength, dia ada volts per meter, ataupun there is another unit that can represent electric field strength. If you know what is the answer, please comment. Soalan dia apa? What is the alternative unit for electric field strength? Here it is said it is volt per meter. There is actually another definition of electric field strength where it will give a different set of units, although the magnitude is still the same, the concept is still the same. So if you know the answer, please comment. Alright. The axis NP of the molecule is at an angle of 30 degrees to this uniform applied electric field. The magnitude of the charge at P and at N is 1.6 times 10 to the power of minus 19 coulombs. Right. The question. On figure 5.2, draw an arrow at P and an arrow at N to show the directions of the forces due to the applied electric field at each of these points. So, soalan dia ialah nak tunjukkan the direction of the force applied on the molecule at points P and N, where P is the source of positive, N is the source of negative charge of the same molecule. So we have a molecule with both positive and negative charge points. So what is the direction of the force? That is the question. So now we are given the electric field lines. So dia daripada kiri ke kanan. So we know by definition of electric field okay, by definition of the electric field, positive goes to negative, right? So ni start lah kan. So kalau positive, we have a positive source kat sini kan. So what happens? Positive, dia akan ke dalam ke keluar? Dia akan ke luar. So the direction of the force acting at P would be in the same direction of the electric field. But for the negative point, it will be actually going against the direction of the electric field. So this is how we draw the direction of the force of both points P and N. Okay. Straightforward Macam ni kita nak tahu, positif dia akan pergi attracted to negative. So sebab itulah direction of the force at P ni dia kena pergi ke arah negatif kat sini. Kalau N dia tak boleh pergi ke negatif. Similar dia panggil apa? Similar signs will repel each other. Itu yang ada dalam notes hari tu kan. So negative to negative dia akan repel. Positive to positive akan repel. But positive and negative they attract between each other. Okay. Bila the same signs repel each other tu maksudnya dia lebih pada dia positive people with positive people, then they will tend to stick together and they will move forward together. Gitu. Alright. On figure 5.2, okay, that is the first question. So dapat now calculate the torque on the molecule produced by the forces in one. Tiba-tiba ada torque pula. Masuk pula forces chapter yang sebelum-sebelum ni kan, chapter 5, chapter 6 kan. So sabarlah. So that's why I said walaupun benda ni cerita pasal electric field, tapi dia punya forces, power, intensity and what not, those are evergreen concepts that are applied in different fields. And we are in electric field. So the same concept tapi dia apply dekat bidang elektrik. So sama juga nanti bila kita masuk circuit, dia akan masuk juga kat situ. Tapi the laws and the principles yang belajar waktu awal dulu, they basically akan digunakan untuk application yang berbeza-beza. So kat sini lah kita nampak the same principles, the same laws, but applied in different fields kat situ. So now the definition of torque, kalau siapa yang boleh ingat, torque is the force multiplied by the perpendicular distance of the force acting from a pivot kan. From the point yang dia tak ada force kat situ kan, dia pusing kat situ kan. So tau, the definition, the symbol of torque is tau, equals to force F multiplied by the perpendicular distance D. So I labeled D as D perpendicular line. So kat sini there are a few things that you need to understand. Dia suruh kita cari calculate the torque on the molecule produced by the forces. So we have two forces yang ada, which is from point P and point N. So this is where the torque can actually act. But because we assume that the molecule is stationary, that means stationary tu ialah dia berada dalam equilibrium lah kan. So the forces acting, the rotational, the angular forces acting, which is torque, menyebabkan benda tu dalam equilibrium. So we can assume, for example, either we set point P as the pivot ataupun we set point N as the pivot, where dia punya force tu takkan ada lah kan. Okay. So the distance, the effective distance between P and N is given already, 2.8 times 10 to the power of minus 10. But we need to find what is the perpendicular distance. Okay. So first, kita gunakan formula. Okay, we have another formula. This is probably a new formula. Force is equals to the charge multiplied by the electric field strength. Sebenarnya electric field strength tu lah, E is equals to F over Q. Tapi sebab kita nak cari force tu, force ni force apa? Force electric field force. So sepatutnya E equals to F over Q. So kita rearrange the equation, kita dapat F equals to QE. Here force is equals to QE. Q tu apa? Ada confusion, Q besar, Q kecil. Yang penting apa-apa yang kolom tu, itulah Q lah Sebab beza dia, Q besar tu to show it is a source of charge. Kalau Q kecil tu is just a test point, a charge test point yang ada dalam field kat situ. So don't be confused lah, insyaAllah. No worries lah. Melainkan you nak ambil physics Olympiad, tu mungkin pening sikit lah. Tapi kalau yang ni dia straightforward. So maksudnya kita tengok kat sini, dia ada dua je value kan. We have Q here, the magnitude of the charge at P and at N, which is similar, 1.6 times 10 to the power of minus 19 coulombs. And then we've got the electric field strength here given as 50,000 volts per meter. Okay, you can substitute E into this one, you can substitute Q into this one. Problem ni lah nak tahu D. D 2.8 ni, this is not the perpendicular distance to the force, betul tak? Sebab force ni, they're acting at an angular kan, which is 30 degrees. Okay, so what we have to do, kita nak kena cari dia punya perpendicular distance. Let's say for example, kita nak ambil force yang mana satu. It's either N or P lah, both also can. So kita nak ambil, here we know that the value of D, okay, this is given as D kan. Kalau perpendicular distance is actually perpendicular to the electric field punya direction. So D perpendicular is equal to D sine 30 degrees. Okay, which is taking the sine lah kan, because this angle is 30 degrees, so this angle is also 30 degrees. The formula for sine is opposite divide by hypotenuse kan. Kita nak cari perpendicular distance kat sini. Okay. So this is D sine 30. So you get here, multiply this distance with this force, ataupun this force. Cuma yang ni kita tengah tunjuk force yang kat sini lah force acting around point P. Okay. So substitute the values, plug in the values into the equation, and you get the final answer is 1.1 times 10 to the power of minus 24. Watch out for the units. It is going to be newtons meter. Sebab force newton, distance is meter. Kalau you nak main columns, volt per meter times meter, so dia akan jadi column CV lah kan. Tapi CV ni agak pelik sikit lah. Dia punya units kita jarang guna CV. Tapi torque kita ada guna newtons meter. Okay. Habis question number 1 in the tutorial. Okay ke? Boleh? Moving on, the second question, which is I took only the two questions, question 1 and question 3 from your tutorial book, so you can actually try to do the second tutorial sendiri. Now, kita tengok the definition of an electric field strength. So here, electric field strength at a point is the force per unit charge. So this is actually using the definition that the formula that we used previously. Is the formal definition is force per unit charge acting on a small positive charge placed at that point. Although we know there is another definition which you guys have already answered betul, semua betul, which is E is equals to Fe over Q lah kan, which is Newton per coulombs. Okay. Question yang tadi tu, okay, Nurin Afika, for that question, our pivot we could assume it at N or P. Betul, it's either N or P, dua-dua boleh sebab they cancel each other out. That's why we have equilibrium and the molecule is static. So here, going back, definition of field strength, here the unit is newtons per coulomb, yang you all jawab tadi lah kan. Adapun definition yang sebelum ni ataupun the value of the electric field strength given by the question previously was volts per meter, which is the potential difference over the distance of the field, electric field. So it is just a formal definition. So to set some standard rules, we will be using this definition of electric field strength. At the point is the force per unit charge. Okay. Acting on a small positive charge placed at that point. So now, kita nak tengok, a uniform electric field is produced by applying a potential difference, V, ini kita tahu V kan, 1200 volts kan, across two parallel metal plates in a vacuum, as shown in figure 4.1. So dia vacuum lah kan, sebab kalau dia bukan vacuum nanti akan adalah pertembungan, nanti lah, nanti mungkin Ami kan, semalam dia tanya, dia Brownian motion ke? Mantap sangat lah. Terkejut dengan Brownian. Ini dah tahu pasal random motion ni luar biasa. Because I myself main dengan Brownian, dengan Winier ni, waktu tengah buat programming kena observe different random X-ray particles dalam kita punya cone beam image dalam CT, dalam computer tomography. Sekali tengok, charge particle moving in electric field, observe Brownian motion ke tak. Mantap lah, generasi hebat memang young talent program betul lah. Okay, okay, the separation of the place is 14 millimeters. A particle P with charge 3.2 times 10 to the power minus 19 coulombs. So kat sini kita dapat this is Q. Okay, and mass 6.6 times 10 to the power minus 27 kilograms. This is the mass. Sebab tu dia macam ada confusion kan bila kita tengok notes tadi semalam. I think was it in this group or was it in the other group where where it says that W is equals to 0 kan, the weight is equals to 0, but it is not actually we assign it to 0, tapi lebih kepada the mass is actually negligible. Not the mass is negligible, but the term W equals mg is negligible because it is small enough to be assumed to have a very minimal effect on the entire system kat situ. Tapi dia ada mass juga lah kan. Okay, dia ada mass. Even protons and electrons pun ada mass. You are actually given the formula of the mass, resting mass of proton and electrons in your exam paper. Okay. So dia kata with the charge 3.2 times 10 to the power minus 19 coulombs and a mass 6.6 times 10 to the power minus 27 kilograms. Starts from rest at the lower plate. Okay. So dia tak bagi tahu lah positif atau negatif kan. Cuma kita boleh assume kalau dia start daripada sini, daripada bawah pergi ke atas, so bawah plate dia apa? Charge apa? Sila jawab dalam comments. Kalau dia bergerak daripada bawah ke atas, so charge bawah ni, plate charge bawah ni dia sign apa, kalau atas ni sign apa. Okay, sila answer dalam komen. So dia kata starts from rest at the lower plate and is moved vertically to the top plate by the electric field. Calculate, number 1, the electric field strength. Nak cuba jawab, bawah plate, plate bawah sign apa, plate atas sign apa. Kalau positif. Okay. Bahaya kan sekarang ni positif kan, positif COVID. We try to avoid positive. Okay. Calculate the electric field strength between the plates. So we can use the definition. So kalau kita tengok definition E equals to FE over Q, nanti kita akan blank lah kan, because kita tak tahu force dia apa. Unit charge kita tahu lah 3.2 kan. Tapi kita tengok the definition can also be E equals to V over D. So we have got the voltage 1200 and we've got the distance 14 millimeters. So this is actually a uniform electric field lah kan, because dia 2 parallel plates, lepas tu tak ada gangguan, tak ada apa-apa. So dia masukkan values, so kita akan dapat E equals to this value, 8.57 times 10 to the power of 4 volts per meter. Okay, thank you very much semua yang telah menjawab bawah positif atau negatif. Betul, dengan syarat charge dia tu dia bawah positif atau negatif dengan syarat charge dia tu adalah positif, small positive charge kan. Kalau dia letak negatif elektron, negative electron charge, dia terbalik lah kan. Okay, so the work done on P by the electric field, so yang ni dia ingat balik, this is actually another equation that you need to memorize lah kan, it is not given. Work done, the definition of work done, kalau work done dalam kita punya dynamics, dalam forces yang sebelum ni, work done is equal to force times distance lah kan. Cuma yang ni tak ada lah So work done is equals to QV. Dia boleh jadi Q besar, boleh jadi Q kecil. It's okay, jangan risau pasal Q besar, Q kecil. Dalam hidup ni banyak benda lagi kita nak fikir pasal masalah. Yang penting, kalau you nampak Q, you nampak column, that is the value lah kan. Unless dia memang untuk nak confusekan you. So W is equals to QV. Alright. The work done is equals to the amount of charge multiplied by the potential difference. Plug in the values into the equation, then you'll get the answer in joule. So yang ni kalau you jawab CV lagi sekali macam pening lah. Macam dia boleh jadi Newton meter yang macam torque hari tu, yang the previous question, ataupun another unit is joule. Okay. Well, they are actually the same thing lah kan. Soalan daripada Amir, is the electric field strength unit interchangeable between volts per meter and newtons per coulomb? Yes, it is, sebab they have the same definition. Cumanya tak ada cuma, memang betul lah. Volts per meter or newtons per coulomb. Ya. Cuma lah, adalah cuma, ada sikit lah cuma. Cuma dia, kalau soalan tu minta you jawab dalam volts per meter, jawab dalam volts per meter kan. But the value will be the same. Dia tak ada main dengan milli, senti, no. The value is actually exactly the same. Alright. So the gain in gravitational potential energy of P. So this has got something to do with conservation of energy lah. The question that I posted earlier. So pagi-pagi lagi dah fikir pasal you all. So dah siap-siap. Definition. Okay, revise the definition of conservation of energy. So kalau siapa yang ni, boleh tak komen dekat Telegram, dalam Telegram group kita lah. Okay, kita tadi dalam my poll quiz tu, dia ada 4 option kan. So the answer is the final one lah, D. So what are actually the first, second and third option punya jawapan sebenarnya? Maksud dia apa? I was asking the principle of conservation of energy. That is the question. So the answer is D. Okay, where energy cannot be created or destroyed, it can only transfer itself from one form to another. That is the conservation of energy, 100%. Okay, cumanya ada jawapan A, ada jawapan B, ada jawapan C, and these three are not all made up laws. They have the three of them actually represents a unique law ataupun teori. So cuba jawab option A ni sebenarnya refer kepada law apa, teori apa. Option B apa, option C apa. Okay, jawab kat mana? Jangan jawab kat sini, jawab dalam Telegram group kita. Alright. Part number 3. The gain in gravitational potential energy of P. So kalau kita tengok kat sini memang adalah gain in gravitational potential energy because dia naik ke atas kan. Dia naik ke atas. Yang ni dia ada kaitan dengan milikan lah kan. Memiliki, milikan. Although dia punya distance tu very small, 40 mm, but kita tengok berapa banyak potential energy yang dia dapat kat sini, 14 mm. Okay. So this P point, positive charge lah, kita assume positive charge point, bila kita activate kan the entire system, dia akan naik ke atas. Alright. So the work done on P by the electric field, bila dia naik kat sini ialah, this is the value lah kan, untuk dia naik ke atas. So this is the amount of work done. What about the gain in gravitational potential energy? It's not going to be that tough. It's quite straightforward. It's going to be mgh lah, ataupun mg difference in h. Kalau you nak letak difference h kat sini pun boleh juga. You are given the mass, you assume g is 9.81 and h is 14 millimeters. Make sure you convert it correctly, and then you get the answer. Gain ataupun change in gravitational potential energy of P is this value in joules. Right. So now what about the gain in kinetic energy of P? So kalau ikutkan macam, senang kan? Gain in gravitational potential energy, P mestilah sama dengan kinetic energy, betul tak? Conservation of energy. So siapa yang jawab the answer is 9.06 times 10 to the minus 28? Salah. Why? Because you are discarding the effect of work done. Maknanya ada work done untuk dia naik atas. So not all gravitational potential energy is converted to kinetic energy. Ni nak kena faham. So work done, kita boleh assume it is work loss. Amount of work used by the electric field in order to move the point P. So the formula is change in kinetic is equals to work done minus the change in potential energy. So the work done minus the gain in potential energy. So the gain in kinetic energy of P ialah this value. Although kalau ikutkan sikit sajalah kan, dia may change kat situ sebab dia 40 mm saja. So from here, kinetic energy straightforward lah kan. Kinetic energy, dia punya formula macam kalau potential energy mgh, kalau kinetic energy ialah half mv squared. So we use half mv squared in order to answer the speed of P. Delta K is equal to half mv squared, V equals to this one, substitute the values, substitute the change in kinetic energy here, and then you get the value, the speed of the charged particle, bila kita activate the system, daripada bawah ke atas, they shoot up 3.4 times 10 to the power 5 meters per second. Laju lah. Okay. Alright. Any questions? Dia main-main formula, faham soalan kan, nak kena faham soalan tu. Okay, boleh bernafas sekejap, 2-3 minit. If you have any questions, you can drop in the comments section, ataupun kalau tak, dekat ya Telegram nanti pun boleh jawab. Power nap 2 minutes, boleh lah. Alright, moving on, let me just give you an overview of what this chapter, sebab ada di dalam feedback notes korang. I think siapa lah, quite a number jugalah yang requested for macam kalau kita boleh buat satu kesimpulan for every chapter ni, apa formula-formula yang kita kena tahu, apa formula yang kita kena hafal lah kan. So benda ni sepatutnya you all boleh produce yourself ALFT KMS 1.2 ataupun collective within you all punya 3 classes ni pun kalau boleh buat satu formula sheet yang cantik pun, that would be the best lah kan, yang combinekan semua chapter-chapter, lepas tu dia boleh tunjukkan kan. So sebab benda tu pun yelah, takkan nak spoon feed kan, seperti boleh lah buat kan, lagi-lagi yang talent program kan, semua orang kan. But I'll just give you a tips ataupun just a data ataupun formulas that are related to this electric field. So nanti bila you nak jawab quiz esok, esok memang betul-betul esok kan, hari Jumaat kan, first Ramadan terus dapat quiz kan. Okay, so this one, kalau kita tengok kat sini, let me just give you my version of the related data, probably new lah kan, for this chapter. So kalau kat sini you have to know these three data, but don't worry because these three data memang ada dalam your punya question paper, okay. If nanti tapi kalau untuk quiz esok dia tak bagi lah. Untuk quiz esok dia tak bagi. So adakah quiz esok akan menggunakan benda ni? Who knows, probably, I don't know. So kita tengok, we have got the elementary charge value E, is in columns, 1.6 times 10 over minus 19. Observe the magnitude lah selalunya kan. Kalau orang buat careless mistake, selalunya ialah dia punya magnitude kat sini. Rest mass of electron ialah 9.11. Advance betul sekarang dah ada kat calculator dahsyat sangat. Rest mass of proton is this one. Alright. And then the formula constant for this chapter sebenarnya tak banyak, ada 3 je yang betul-betul kalau ikutkan. Work done on an electric on a charge by an electric field, W is QV, the unit is joule ataupun newton meter, ataupun yang kalau yang nak pelik-pelik tu boleh letak, tapi yang standard kalau work energy ialah joules lah kan. So is QV. Work in an electric field is QV. Q kecil, Q besar, depends kan. And then kita ada electric field strength, dia ada 2 je, V over D dengan F over Q. We've got volts per meter yang tadi Amin tanya kan, is interchangeable. It is actually the same thing, but yalah, dia punya physical interpretation tu mungkin different lah kan. But although when we calculate something and the units in volts per meter, we can actually translate it in terms of charge values kat situ, if we know the electric field force. So they are actually interchangeable and relatable between each other. So that means we can do E equals to V over D equals to F over Q. So ni je lah electric field. Okay. Dia sebagai mukadimah lah kan, because you got next ialah chapter 11 and chapter 12. So that's where the applications comes in lah kan. Dia macam waves lah kan, waves part 1. Oh, stroll in the park, semua macam okay, tak ada masalah. Masuk je part 2, Doppler kita tak assess kan, tapi tengok electromagnetic waves, Allah, benda ni kan. Lepas tu masuk dia punya application, superposition. Memang penggal kepala lah kan. So nak ceritanya, kalau untuk this chapter saja, the quiz that you are going to face tomorrow, it will be concerning on this formula saja. Tapi dia tak consider semua formula-formula yang sebenarnya you kena tahu kan. Dia punya apa, S equals to UT plus half AT squared lah, F equals to MA lah, itu semua tu I don't include here lah, because that is not new for this chapter. It was probably new during the previous chapters, tapi you kena tahu jangan tu kan. So sekarang ni tengah buat chapter 10 kan, bukan tengah buat chapter 6 kan. Alright. Okay, baru nak gembira, oh ini saja yang akan terlibat. Ya betul. Tapi nanti nak buat Newton's second law of F equals to MA apa tu, takkanlah nak ulang balik kan. So ni just upgrade lah kan, apa yang tak ada sebelum ni yang baru ada sekarang, ada dalam slide ni. Okay. Okay, that is on electric field. Wallahu a'lam. So now, as closing remarks, I'll give you a bonus slide, insyaAllah. Just bear with me for the next 10 to 15 minutes. Lepas tu dah power nap. Danny masih lagi power nap ke ataupun dah bangun? 2 minit saja. Alright. So bonus slide, okay, bonus slide ni dia taklah terlalu bonus sangat. Dia akan menyebabkan ada recall jugalah, macam biasalah So kita tengok recall in chapter 06, work, energy and power on the principle of conservation of energy. It's actually the question yang Paul tanya tadi tu lah. Okay, what is the principle of conservation of energy? Dia kata energy, it can't be created or destroyed by us. Okay. Of course, energy is created by Allah Subhanahu Wa Taala. Allahul Khaliq. Okay, it's okay. Because this principle is based on our observation in the physical life at the moment. So energy cannot be created or destroyed. It can only be converted from one form to another. For example, yang typical punya example atau analogy is the conversion from potential energy to kinetic energy. Dia akan bagi dalam pendulum, kan? Cuma kalau dalam kita punya discussion dalam electric field ni, when a point charge goes up, so dia ada conversion, dia punya gain in potential energy, lepas tu dia ada gain juga dalam kinetic energy kat situ. Tapi dia akan ada work done, so dia ada loss kat situ. So kat situ kita nampak the system is conserved. Alright? From here also rise the concept of efficiency ratio, betul tak? Kan? Kalau ingat balik chapter 6 lah. Sebab chapter 6 saya tak ada lagi dengan saya tak wujud lagi dalam hidup you all, kan. Saya hidup you all waktu akhir chapter 7, waktu apa, kalau dalam group 1.2 ni, waktu practical tu, kan. Okay. So yang ni bergantung solely on the previous things that you've learned before this. So dia kata, based on the principle of conservation of energy, we know the concept of efficiency ratio. That means, apa efficiency ratio ni? It is actually the ratio between useful energy output from the system to the total energy input. So, this output over input of the system. So, lepas tu dia guna term kat sini useful. Useful ni maksud dia apa? Benda yang intended from the system. Contoh apa? Okay, we have an aircon. Siapa yang sekarang tengah duduk dalam bilik aircon? Oh, tahniah lah, kan? So, aircon, the system of the aircon, air conditioner is actually bukannya dia tiup udara sejuk, kan. It is not that. The function of an air conditioner is actually to condition the air temperature so that it would reach the desired temperature. Okay, so the useful energy output would be the temperature, kan, the thermal energy lah, kan. Thermal energy depends lah, kan, you nak letak 16 darjah Celsius ke, 24 ke, 32 ke, tak ada sampai 40, kan. Ada sebenarnya kalau you pergi dekat overseas, macam dulu belajar kat UK, kan, dia ada heater instead of ada aircon. Dia panggil aircon, yelah, dia tak panggil air conditioner lah, kan, tapi dia ada heater untuk nak memanaskan bilik tu because of winter. So dia boleh, kalau dalam kereta-kereta import ni, dia ada dua cara lah, dua mode lah, kan. Satu ialah untuk nak keluarkan angin sejuk, to condition the temperature of the car so that it will become cold, or to condition the temperature of the car for it to become warmer. Okay, kat situ. So the useful energy output for an example of an air conditioner would be thermal energy. But we know there are also kalau opposite bagi useful apa, useless. Kalau useful ialah thermal, kalau air conditioner. Kalau dalam air conditioner, useless energy output ialah apa? Contoh, sound energy, betul tak? Macam contoh aircon, dia keluar bunyi. Buat apa kita nak keluar bunyi? Kita bukannya nak bunyi, dia bukannya radio, kan, ataupun phone yang kita nak communicate. We do not want that. So noise, sound, itu yang nama dia sound, dia akan jadi noise, betul tak? Okay. So kalau dalam efficiency ratio, we do not take into account the we do not take into account the noise that is being made, the energy, the sound energy, tapi we only consider the thermal energy kat situ. And then we divide it with the energy input. Energy input tu more probably in terms of power and electricity lah, kan. And then we get the efficiency, kan. Okay. So kat sini, kalau kat Malaysia, dia guna yang label ni lah, kan. Penggunaan tenaga, energy consumption. Ini you boleh tengok lah dekat you punya aircon nanti, kan. Berapa bintang. The more number of stars, that means the more efficient the system is. Okay, appliance type, dia akan bagi lah. Yang ni semua ada dalam website TMB. You boleh tengok lah, Suruhanjaya Tenaga, kan. Tenaga bukan ada Mosti lah, kan. Tenaga sekarang dia ada mewah. Energy and water, kan. Tuan Ibrahim Toman. Alright, so dia kata kat sini lah. So the importance of understanding conservation of energy ataupun the practical use, we can determine the efficiency ratio, and to that we can actually label our electrical appliances, betul tak? Okay. When we label the electrical appliances, kita boleh tahu yang mana satu efficient and not efficient, and then kita boleh decide lah, as a consumer we can decide which one we want to purchase, for example. So kalau dekat tempat-tempat lain, kalau kat Malaysia ni lah kan, kalau dekat tempat-tempat lain dia bagilah dengan color code dia kan, green and red. So red dia inefficient lah, G lah, almost fail lah kan. Kalau A+, kalau kita A levels dia ada A star kan, dia guna A+++. Mungkin satu yang nanti SPM pun kita ada A+++. Kan, mungkin SPM sekarang SPM A+ je kan. Kalau A levels dia ada A star kan, sekarang ni plus. So this is the application of energy ataupun application of conservation of energy and the efficiency ratio. Okay, so now let me just ask each and every one of us to reflect on a few verses of the Quran in terms along the lines of conservation of energy ataupun in terms of this efficiency concept. Alright. If we look in the verse of Allah SWT in Surah Al-Rahman, Allah SWT says, فَبِأَيِّ آلَاءِ رَبِّكُمَا تُكَذِّبَانِ. And we know this is actually a famous verse kan. A famous verse yang memang ayat yang famous yang dia ulang banyak kali kan. In fact, it was repeated 31 times in the same chapter of Surah Al-Rahman in chapter number 55. Yang mana dia punya persoalan yang Allah SWT give us in this chapter is, so which of the favors or ni'mats, ala'i, is the favors atau bounties or the ni'mats of your Rabb, your Lord, would you deny? فَبِأَيِّ آلَاءِ رَبِّكُمَا تُكَذِّبَانِ. So in terms of the inputs yang Allah SWT has given to us, okay, the inputs, abundance, multitudes, memang luar biasa, sangat-sangat banyak Allah SWT dah bagi kita sangat-sangat banyak nikmat. From the most subconsciously favors that Allah SWT has given us, for example, breathing, looking, hearing, sensing, all of this 5 senses yang ada kan, 5 main senses kan. Setengah orang tu dia ada 6 sense pula kan. 6 sense apa? Boleh kesan ada berapa lah kan. That means subconsciously we know that there is a nikmat, tapi kadang-kadang kita terlepas pandang. That is subconscious. And benda yang consciously we know that ada nikmat yang Allah SWT bagi, contohnya apa? Allah SWT has given us the nikmat of having a roof under our heads, for example. Allah SWT has given us the nikmat of being able to communicate via the internet during this PKP period, for example. And this is a form of nikmat. And also another form of nikmat that Allah SWT has given to us is what? Being able to proceed with our lives. We've got feelings, we've got the heart beating. Try to imagine, man, those who are affected by the coronavirus, they are positive. Even to breathe also is going to be tough for them because the virus has infected their lungs. Betul tak? Sebenarnya tak perlu tunggu coronavirus pun untuk nak tahu betapa nikmat tu ditarik. You can actually observe from lung cancer patients, which my research is all about kan. I observe the 3D images of lung cancer patients. Memang huru-hara lah dia punya cancer cells kan, all over the place. So nak ceritanya, before that happens, Allah SWT has given us loads of ni'mah. Allah SWT has given us the feelings of being a Muslim. Selalunya kalau mana-mana ceramah dia kata nikmat terbesar, nikmat iman dan nikmat Islam and whatnot. Being able to walk our life, being able to read and understand. And for you guys, young talented people in the young talented programs, Allah SWT has given you the ni'mah of actually having the opportunity to further your studies overseas, for example kan. Dalam keadaan I've heard loads of banyak cerita all this while throughout the years yang mana marah dah tarik, dah tak ada dah, boleh pergi ke overseas kan. Sedar-sedar tengok ada lagi this small group of people, 50 people like what we in 2004-2005 had gone through, ada juga sebenarnya course ni masih lagi ada kan. So Allah SWT has given these inputs kan, this energy inputs yang banyak sangat kan. So just to ponder on this, Allah SWT has given us loads of inputs. Nak cerita banyaknya tu, dia ulang benda ni 31 times kan. And then there is another verse, and this verse is very famous yang memang kita baca tiap-tiap kali sebelum habis kelas kan. In Surah Al-Asr, Allah SWT says, A'udzubillahi minasyaitonir rajim, innal insana lafi khusr. Verily indeed the mankind, human being, lafi khusr, is indeed they are in a loss. Okay, indeed, mankind is surely in loss. This chapter allows verse number 2, chapter 103, verse number 2. So when we observe here, when Allah SWT says is a loss, so based on the energy ratio, energy output over energy input is equals to the efficiency. If we are at a loss, that means kita mungkin dekat D ataupun C, ataupun kita nak bintang tu mungkin 1 ataupun separuh kan. Why is it this way? Is it because we've got lots of input yang Allah SWT bagi? In order to achieve efficiency, do we have to reduce the number of input? No kan. In terms of efficiency, input tu tak kisah berapa banyak input yang dibagi, tapi the output must be low, must be comparable, must be more than the input that has been given to you. So now let us reflect on these 2 verses with the principle of conservation of energy in terms of output and input to achieve a higher efficiency. But then Allah SWT says mankind is surely in loss. Because of why? Most of us do not actually give the useful energy output, but instead we waste lah kan, useless. We actually convert all of the ni'mah that Allah SWT has given to us into useless energy output that actually affects the efficiency ratio of us being a human being. That Allah SWT says, Innal insana lafi khusrin. We are in a loss. That is the dilemma that we are living in. Allah has given us abundance of favors. Favors tu nikmat nikmat, kelebihan dan sebagainya. Have we produced an efficient output out of all of them? That is the question that we need to answer. But to do that, macam dalam analogi air conditioner tadi tu kan, air conditioner dia keluarkan banyak-banyak jenis energi. Dia ada energi thermal yang kita tahu, dia ada energi apa lagi, energi sound energy kan, acoustic kan, which we do not want. But we define the system as an air conditioner system. If we define that system as something to do with acoustics, so the thermal energy is useless. The useful one is the sound. Tapi we have defined air condition kenalah thermal energy, not sound energy. That means we define the system to determine which is the useful energy output. So now, as a human being, we are a system. For example, analogy, we are a system. What is actually the type of useful energy output? We need to define it. Only once we define that what is the useful energy output, then only we can plug in into the efficiency ratio equation to ensure that we are not in loss. Actually, we are in beruntung lah kan. Aflah. Qad aflahal mu'minun. Verily, the believers are winners. Aflah. So, my question kat sini, tak tulis kat sini lah kan. Have we produced an efficient output out of all of them? To actually answer this question, we as a system, we need to define the fundamental question is, we as a human being, what is the required useful energy output? Itu yang kena jawab dulu kan. Because kalau kita nak, have we produced an efficient output of all of the ni'mah, of all of the inputs that have been given by Allah SWT to us? To ensure that are we producing an efficient output? We have to know what type of output is required by Allah SWT. Maknanya Allah ciptakan manusia ni, what is the desired output? Not desired by our desire, tapi desired by Allah SWT. So, food for thought for you guys to actually ponder, and actually the answer is very clearly stated in the Quran. And Alhamdulillah, we are nearing the month of Ramadan. It is time for us to actually reflect, for us to actually go back to the verses of the Quran, to read and understand, so that what we study, physics, chemistry, mathematics and whatnot, it will not all go to waste. It will actually go to being efficient if we actually define what is the useful energy output for ourselves. Okay, Wallahu a'lam bissawab. I think that's it. For those of you who have already given the readiness to join the Quranic circle that I will be organizing, ahlan wa sahlan. It's very good for you guys to have on board. Inshallah, I'll be giving information to you regarding the group. Apart from that, Hopefully everyone will be able to celebrate Ramadan, the month of Ramadan, the blessed month of Ramadan, so that we actually can get reap the benefits of this holy month. My salam, my regards to your parents. InsyaAllah, maknanya apa? Kirim salam lah. Kirim salam kat your parents. InsyaAllah we'll meet again in another session. The earliest would be on Monday. Not to say I am going to meet you, you are going to meet me lah, because I cannot see you. Contohnya. So on Monday we'll have a discussion on our quiz that you'll be taking tomorrow. So hopefully you guys can excellent dalam quiz tu. If you have any questions or whatever topic, you can always ask me sama dalam group ataupun nak PM pun boleh. We pray to Allah SWT, that Allah SWT guide us in the straight path. InsyaAllah, aqulu qawli hadha wa astaghfirullah li wa lakum. We'll end our session with tasbih farah and surah al-As. Subhanakallahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal asri innal insana lafi khusrin illa alladhina amanu wa amilus solihat wa tawassaw bil haqq wa tawassaw bis sabr walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.